So let's take a look at the two-sample proportion test and the confidence interval to go along with it in R. The idea here is that we want to test a claim about a significant difference between two proportions from independent groups. First, load in all of the normal packages that you need. We will use at least some of these. But the claim is that Ford and Chevy differ in the proportion of their electric vehicles that are battery electric vehicles. So there's these BEVs, battery electric vehicles, and then the hybrids that are plug-ins. So we're going to bring in this file here. It's up in e-learning if you need it. And just to see the dimensions of this, once you load it in, you can see there's over 121, close to 122,000 electric cars. Most of these cars are from state of Washington. Here are the variables that we have for this data set. See that we have 17 different variables. And you get the VIN number, I believe that's a VIN number, and then some location, the make, the manufacturer, and then the model. And a variable that we're going to do a little bit with is the electric range. This is the distance that the electric car could go on one battery charge. Another variable we're going to look at is, does the car have clean alternative fuel vehicle eligibility? And if it does, then presumably you'd get a tax break when you file your next tax return. Now, as you can see, we have all kinds of different makes, Tesla and Audi and Ford and Nissan and so on, Chevrolet. But we're only interested for our problem in Ford and Chevy. And so I'm going to go filter out some of this data so that I do have just a couple of different car manufacturers. Okay, so I'm going to filter out electric cars, and if the make of the car is Chevy or Ford, I'm throwing in Kia there just for comparison purposes, and we'll actually use it a little bit later. It's important to note here that all Tesla and Nissan EVs are battery electric vehicles only. They're not hybrids. All right, so we'll filter that out, and you should see in this column here, the make column, as you go down, all you see are Fords and Chevys and Kias, and that's it. So we just have the first couple. All right, so we're going to do a little exploratory data analysis here. And one of the things that you want to do if you're going to compare two qualitative variables is to look at a frequency table comparing the two. So there's a nice function here called cross table. You say it's like crosstabs, and you just put in your two variables. So we want to look at the relationship between the electric vehicle type and the make of the car. And what happens when you do this is it creates a nice table for you. Enlarges here to take a look. So there it is. It's a very extensive table. It has all kinds of things in there. What we're going to pay attention to are the frequencies. So there are 5,880 Chevys that are battery electric vehicles only. And for Ford, it's only 2,917, and for Kia, 34. So when you add these three numbers together, you get the total number of BEVs, battery electric vehicles. The other option for vehicles in this data set are the plug-in hybrids. And so you can see that each one of those manufacturers has several of those as well, but more BEVs than just plug-ins. Many of the numbers under here are proportions. So for example, this one right here, if you take the 12,000 and divide by the 22,000, you're going to get about 55%. Yeah, so if you come over here, 73% and then 27%, these are the conditional proportions using the make of the car as the independent variable. And then if you wanted to calculate the conditional proportions going the other way, well, here you can see the difference between the battery powered vehicle and the plug-in hybrid. So the smallest numbers down here, if you add these 6, then those 6 would add up to the 100%. And then you've got row proportions and column proportions in there. So, what can you make out of the table? We're going to calculate the proportions that we need there, but it's really looking at these numbers down in here, these conditional proportions, that really lead you to the relationship of between the two variables. We'll pick out one of them. We're going to take the 58,000 and divide by the 10,000. Well, that looks to be about, what is it, 55%. So there's that number right there. And then if you take the Ford 2917 and divide by the 6517, you get this proportion. Then and then if you look at Kia, just for comparison's sake, you can see many more of their vehicles are battery electric as compared to the non-battery electric, the plug-ins. And so there's only 4,700 here. So you divide 3,400 into 4,700 and you get a much higher percentage. So we're really comparing these three proportions in here. And you can see there's some differences. Kia seems to have a much larger percentage of battery electric vehicles. And even Chevy has a lot more than Ford. But if you come down here to the plugins, you can see Ford leads the way, Kia is the least percentage, and the Chevy is kind of in the middle. So there appears to be some differences in here that we need to go investigate. These are the numbers that we're interested in. The first two we're going to get from the table, and then we're going to divide them to get the proportion. So the number of Chevy battery electric vehicles is the 5880. And the total number of Chevys, here's the Chevy column, would be down here. So if we divide those two, we have the proportion of Chevy EVs that are battery EVs. And you can see there's our 0.546, which is this number up here. Okay, now what are we going to compare that to? We're going to compare it for this test. We're not going to use the Kia numbers, but we're going to use the Ford numbers. So we look at the same two numbers up here for Ford, the 2917 and the 6571. And there they are. If you do the division here, you get this 0.444, which is the proportion here that we looked at earlier. So there seems to be a big difference, close to, if you look at these percentages here, almost 10 percentage points. When your sample sizes are very large like they are here, that difference is huge. All right, so the next thing we're going to do is to go ahead and draw this multiple bar graph. We're going to use the make of the car, the Ford and Chevy and Kia down on the x-axis for vertical bars, and then we're going to color by the vehicle type, one of those two types, battery or hybrid. And then remember this function here, this argument here is the position equals dodge, that changes the bar graph from a stacked bar graph to a multiple bar graph. And it looks like I threw in a couple of titles here. So let me go ahead and run this and enlarge the graphing window. And here you have it. You have the title up here, and you've got the two different options. You've got the battery EVs here, and then the plugins there. You can tell by these graphs with these three different manufacturers that both Kia and Chevrolet, they have more battery electric vehicles than Kia. Kia looks like it has 2 to 3 times as many battery electric vehicles than plugins. The trend is different for the Ford. Ford has more plug-in hybrids than they do for the battery electric vehicles. So we see some differences in the graph as well. So the next thing we're going to do is to run the hypothesis test to decide if the differences that we just now observed are statistically significant. So I'm going to take those numbers from our sample proportions that we found down here and assign them to X and N and X2 and N2. And also notice the function here calls in X1 and X2, which are numbers here, and N1 and N2, which are also our N's over here. So we've assigned those numbers, and then here comes your results. You have the data that we entered in, and they don't give you the numbers because we entered in variables. It gives you the test statistic and the p-value here. It says it's a two-sided alternative, 95% confidence interval. Notice both of these numbers are positive. And they give you the two proportions, as we saw earlier. Now you can break this down and get each one of these printed. So I'm going to show you where you find them. You can see that all of these are the results, and you just start typing results 1, results 2, results 3, and so on. When you get down here to estimates, there's two different versions, the first proportion and the second one. So this is how you would have to type it in after you run the results, or the prop.test, to get all of these results one at a time. You get the p-value first, and then you get the two different proportions. And if you want them one at a time, you can do estimate 1 and then estimate 2. Gives you the confidence interval in spot 6, and then tells you what the name of the test is, and then what the data are. Okay, let's take a look at the formal test that we would run then. So we've got all the results. There was a claim made that there is a difference in the two proportions, and the two proportions are the proportion of Chevy electric vehicles that are battery only electric vehicles, and then the proportion of Ford electric vehicles that are the same thing, battery electric vehicles. So when we say that the two proportions are equal, we mean that they're the same, which means there's no difference between them. And then typically we would like to run the test and find a test statistic that leads to a p-value that's less than 0.05 that would lead us to reject the null hypothesis in favor of this alternative that says the two proportions are not equal. And if they're not equal, that means there's a difference between them. We'll use the standard level of significance, alpha, 0.05. And our conclusion is, because p was less than 0.05, is that there's evidence of a statistically significant difference between the proportion of Chevy EVs that are battery electric vehicles and the proportion of Ford EVs that are battery electric vehicles. Okay, so we've got evidence. Now, the hypothesis test just told us, there was a difference. If we wanted to go on further and say, well, what was the difference? That's where the appropriateness of a confidence interval comes in. So we saw up here that you actually get the confidence interval in this statement right here. So there's not a new function that we use. It's just part of the output for the proportions. So let me just say a word about how you interpret the confidence interval in this context. When we calculate a confidence interval in this context, we are estimating the difference between the two population proportions, P1 and P2. Now we're going to calculate a confidence interval, and what we're looking for is something down here, this confidence interval. Notice you got a positive number on the left and a positive number on the right. So I would classify this one as a positive confidence interval. If that's the case, this thing we're estimating, P1 minus P2, is positive, because every number in this interval is positive. And so we would say P1 minus P2 is greater than 0. Greater than 0 in math terms means positive. So if P1 minus P2 is positive, then using a little bit of algebra, you get to this. And there you have it. Not only do we know that P1 and P2 are different, but we now know with the confidence interval that P1 is greater than P2. Similarly, if you want to estimate the difference between those two proportions and you get two negatives, well, that means that P1 minus P2 is less than 0, or P1 is less than P2. We didn't get that here. And the only other strange case is sometimes you'll get a negative on the left and a positive on the right. And if that's the case, then 0 is a number in this interval. And so we say that P1 minus P2 could plausibly be 0. And again, applying the algebra, that's P1 equals P2. Again, when you run this command, you get this, which is positive, positive. And since the entire interval is positive, we say that P1 is greater than P2, or the proportion of Chevy EVs that are battery EVs is greater than the proportion of Ford EVs that are battery EVs. Now, this particular test can be generalized to more than just two proportions. And it turns out that this is the same function that we use for the chi-squared test for homogeneity. And this is where we say a bunch of proportions, not just two, but more than two, 3. So here's where I'm going to bring in the Kia example. So I'm put the two Kia numbers here, along with the Chevy and the Ford numbers. And notice my prop test function, the only difference is it added that third X and that third N in there. So let's go ahead and assign each of these again. and then run it. And then here are our results. Notice that it says the 3 sample tests for equality of proportions instead. The data, chi-squared, again, you have the p-value down here is tiny, gives you now Chevy and Ford, and now we have Kia. And if you'd like some of the individual statistics separately, you can pull in pieces of the results. So there's the chi-squared statistic, degrees of freedom from the test, the p-value of the test, 1.03 times 10 to the negative 201. So very, very small. Both proportions, I say both, but I should say all 3 proportions. And then sample proportion 1, sample proportion 2, and sample proportion 3. Now, when you try to run a confidence interval here, it has no idea, what you're talking about, because, you can only run a confidence interval and subtract 2 different proportions at a time if you're going to estimate the difference. Well, if you have 3, then difference is out the door. So what is it? Yeah, see, it gives you the null. So this one's not going to be one that we use here for a 3 test. And then it gives us the test name, and then it gives us the data that we entered in. Okay, so you have just seen an example of the 2 proportion or now 3 proportion test for equality of proportions. And we also saw a confidence interval in this section as well.